All right, today we're going to take a journey back in time, back to the very roots of structured software development to talk about its original blueprint, the Waterfall Model. Now I know, it might sound like ancient history, but trust me, you can't really get a handle on modern development without understanding where it all began.
And that brings up a really fair question. I mean, in a world that runs on Agile, sprints, and constant changes, why on earth should we care about a model from 1970? It seems totally outdated, right? Well, that's the big question we're diving into, and I think the answer is going to surprise you. To really get it, you have to picture the scene, the early days of software development. It was basically the Wild West, chaos everywhere. Then, in 1970, a computer scientist named Winston Royce came along and proposed a way to bring some serious order to the madness. But here's the really wild part. The super rigid model he's famous for? His paper was actually a warning against using it without some major tweaks. The industry, though, they just grabbed the simple version and ran with it. And, well, the rest is history. They called it the Waterfall Model. And you know what? The name is the perfect analogy. It's all about this powerful one-way flow. So what does that actually look like when you're building software?
Okay, here's the core concept. It's a sequential model. Some people call it the classic life cycle model. But the big idea is that you have to finish one phase 100% before you can even think about starting the next one. It's just this series of separate stages that flow in only one direction.
This quote really nails the whole mechanic. It's kind of like a factory assembly line, right? The thing you finish in one stage, like, say, the requirements document, becomes the essential ingredient for the next stage. Everything just flows in this super clean, logical line.
So the key takeaway here is just how rigid this thing is. There is zero, and I mean zero overlap between phases. And just like a real waterfall, you can't go back upstream. Once a stage is done, it is done. There's no undo button. And that, as you can imagine, puts a ton of pressure on getting the planning absolutely perfect from day one.
So how does this actually work? The whole process has broken down into 6 very distinct phases. These steps take a project from just a glimmer of an idea all the way to a finished product, and then keep it going.
And here they are: requirements, system design, implementation, testing, deployment, and maintenance. A good way to think about it is that each one is like a locked gate. You can't get through to the next one until the one before it is totally finished and signed off on. Let's do a quick walkthrough of each one.
So everything kicks off with requirement analysis. This is where you sit down and document every single thing the client could possibly need the software to do. This all gets put into a formal document, the Software Requirement Specification, or SRS. And once that thing is signed, it's basically frozen in carbonite. It's locked in, no changes.
Next up, that frozen document gets handed off to the design team. They use that SRS to create a complete technical blueprint for the software. We're talking system architecture, user interfaces, database structure, literally every little detail the developers are going to need to actually start building this thing. And now we get to the fun part, the actual coding. In the implementation phase, developers take that super detailed blueprint and they just build. They write the source code, usually in smaller chunks or modules. And as they finish each piece, they do little isolated tests on it. That's a process we call unit testing. Okay, so all the individual pieces are coded. Now it's time to put them all together for the very first time. In this phase, the entire system is tested as one big, cohesive unit. The whole goal here is to hunt down and squash any bugs before the software ever gets near the customer.
With the system fully tested and given the green light, it's go time. This is deployment. The software gets installed and configured on the client servers or computers. This phase also covers stuff like user training, to make sure everyone actually knows how to use their shiny new product.
And last but not least, we have maintenance. The software is live and out in the world, but the job's not over, not by a long shot. This is a long-term phase all about fixing new bugs as they pop up, releasing updates, and adding any planned new features over the product's entire life.
So that's the process in a nutshell. It's clean, it's logical, it's incredibly structured. But that very structure is both its absolute greatest strength and, as we're about to see, its most critical, fatal flaw.
The pros and cons of Waterfall are really just two sides of the exact same coin. On one hand, it's simple, it's predictable, it's easy to manage, because everything is documented and locked down from the start. But that exact same rigidity, that's its Achilles heel. If the client changes their mind halfway through, or even worse, if you got those initial requirements wrong, the whole project could be headed for disaster.
And that inflexibility is precisely why new models like Agile were even invented. So, where does that leave our 50-year-old waterfall model in today's super fast, always changing tech world?
I mean, when you put Waterfall and Agile side by side, the difference is just night and day. Waterfall is sequential and rigid. Agile is iterative and flexible. Waterfall waits to do all the testing at the end. Agile tests constantly from the very beginning. This difference makes Waterfall a much, much higher risk for any complex project where you know things are probably going to change.
So, is it obsolete? Is it useless? Absolutely not. And this is the crucial point. Waterfall is still the best tool for certain jobs. If you're building a small, simple app where the requirements are guaranteed not to change, or for things like government and defense contracts where heavy documentation and a fixed scope are non-negotiable, Waterfall is often the perfect choice.
And this brings us right back to our original question. Why should you study it? Because Waterfall is the foundation. It's the granddaddy of them all. It's the model that taught the entire industry the importance of structured thinking. Every modern methodology we have, including Agile, was created as a direct reaction to Waterfall's strengths and, more importantly, its weaknesses. It is literally the starting point of the entire conversation about how to build software.
So I'll leave you with this thought. The core ideas of Waterfall, things like clear documentation, thorough planning, a structured process, those things never go out of style. They are the bedrock of good engineering. The real question isn't about choosing Waterfall versus Agile. It's about asking what timeless lessons we can still learn from this original giant of software development.